to it. Okay, so I'm gonna go kind of backwards, so you'll see what I mean with the, just so you'll have this stuff on the front end for when you get to the HEC-HMS part. And you can use any version. I'd probably get a 4.3, 4.4, 4.5. I use 4.4 on most of my projects, but I know I use this one on 4.3. And whatever you use, wherever you save it, include that in your folder, what version you used, because you'll want to keep using that same version of HEC-HMS. So you'll start out with a blank model. You'll create a new project and stuff like that, and then you'll have to create.
Are you sharing screen or anything?
Oh no, I'm not. Sorry. Let me do that. So I did 4.3, but there's newer versions available, and you can use those. I've been doing, I think 4.4 is has been my favorite. Not that there's much of a noticeable difference between them, but you just want to, wherever you save it, make sure you know what version it is in that folder, and that way you know, because you want to be consistent when you're opening it again, because it can cause issues.
And you don't want these in ProjectWise, is that right? Or is ProjectWise safe?
You can put them in ProjectWise. It'll create you'll have to bring them out to work on it, but it'll create you would have to bring the whole folder in, because it creates all these different logs and files and stuff. So it doesn't work well within ProjectWise, but you can, when you're done, you can save it there and then bring it back out when you need it again.
Okay, so all right, so pretty much just do this all on your local.
Yes.
Okay.
And then basically with HEC-HMS, so you'll need, you probably won't need paired data for anything on yours, but you will need these 3 parts to get a model to run. Basin model, meteorological model, and control specifications. So this is, and you don't need all, we have a background map in this one and stuff. You don't need all that, but you'll basically set up a basin model, and then you'll need your basin, which will be whatever your drainage area is. And you'll use this sub-basin creation tool and just put one in there. And then that's where you'll need the attributes of that drainage area. So you've got its size in square miles, and then you need its, you can put the initial abstraction, but if you don't, it just uses the default equation and it turns out okay. Then you use the curve number and percent impervious. And the curve number, so how this works is, you have different land use types, right? I could select commercial, and that is about, a commercial development might be 85% impervious. But if I get it, and you can look at tables, and a commercial will have a certain curve number. So say a commercial development is 85 on your curve, or let me pick another number. Say it's 90. I don't know, I'm just making it up. I'd have to look at the tables, but say it's 90 for your curve number. Even though that is commercial development, might be 85% impervious, you would not enter that and the percent impervious. You would do one or the other. So what I generally do is, and how I've written the workflow, almost done revising our spreadsheets to get them in there.
Questions on it.
So I use the curve numbers associated with the land use type, and do not enter the percent impervious except for within the right of way. Wherever we have within the right of way, the only land use I put in is pavement. And whatever the pavement is, I enter, instead of giving that a pavement land use, I give it more of a different land use type, and that's I basically it's the land use type is for not being pavement, even though it is, and then I count it as percent impervious. So that's how I do it. You can't.
Yeah.
And the reason I do that is that way if you have a really big area and you're making changes in proposed conditions, it gives you a better gut feel of whether you did this part right. Because if I just saw a difference in the curve number, I wouldn't really be able to judge if it makes sense or not. But if I see, oh, it went from 1% to 2%, say, oh, okay, that makes sense. Or if it went from 1 to 20, I'd be like, that doesn't make sense because the only portion of the area within the right of way is really small. So it would jump out at me. So I have that stuff written down.
Okay.
I'll walk you through that part. But the main thing is, so you're entering you're creating a model, you're dropping your area in with this, and then you give it your area, curve number, and your lag time with all these options. And then that's it for the basin models.
Okay, so we'll have one of these then. We planned on doing
You only have
all
one
the other.
area.
All right, so here's the plan. We're gonna do just one using hydrograph method, and then all the others we're gonna be rational method.
Okay.
So we were just trying to do whatever the easiest was for us, and that if we just had one to where we just needed to do the hydrograph method, then that would be perfect. But I think we actually have 3.
Yeah, 2,200, 280 and 270.
So we may have to do this 3 times, because we have 3 of areas greater than 200 acres.
Well, the other thing is the hydrograph method works for everything. So really the only deal here is that you can import all your areas into one model. And
Yeah.
each drainage area can be separated. I mean, yeah, we can do the rational method, but this probably computes everything a lot quicker and probably more accurately. We don't have to, I'm just telling you.
I'm just trying to think of easiest way. That's all I care about.
Yeah.
If I were to create a blank one like this, yeah, you could have subbasin 1, subbasin 2, subbasin 3, and you get all your results that way. And then you'll just come in here and put out how did this happen? Let me delete that. Components. I guess make sure you create US customary. That's what messed me up. So yeah, then you could just put as many basins as you need there. Then you would just put in whatever their information is.
Okay.
I'll walk you through the tools on calculating. Oh, okay. So in these, you will select loss method. You'll do none, SCS curve number, and SCS unit hydrograph, and no base flow. And then you would put in your
Okay. So you do that.
number.
You got start with the subbasin tab and you work way to the right.
Yeah. And then you would put in all your stuff in there. And there's not really anything, you don't need anything on that. So
I guess we need. All right, can you talk us through?
and then the other one, so the meteorological component to this one, this is a little bit, so what you would do would be, let's say, create component for each of these, call it, you would do it for each one. They've already done it.
do it for each year, design year.
Yeah.
Do we
And-
need, we normally do it for, uh, what design years do you think we need it, really?
Usually the scopes are written to where you're calculating everything for these 2, 5, 10, 25, 50, 100. So it depends on your project, but you're really only, you're designing to, I don't know what you're, if you're doing like a culvert analysis or something, you'll be designing to one specific event and then checking on the 100-year. But
Okay.
I usually just throw them all in there
All right.
for a project. And all of this is, so you would do, you want to do a frequency storm type for your hydrograph, and then you'll come up to this stuff. I think you see US 9 frequency storm replace. So all that's good. The only thing what you need to do here, it'll be in the spreadsheet I provide. So Atlas rainfall, HMS, this tab here, Atlas rainfall HMS. You'll need to go to this link right here and then navigate to your project location on that site. And then you'll need to pull the precipitation
Yeah.
frequency depths off of
Okay.
that.
Yeah, we've done this before.
Okay. And then that is what gets entered in. If you come over here, this is basically, once you put that here, you copy that in. This is what gets input into HEC-HMS.
Okay.
I think it would be like if I was doing the 2-year, which is probably, I think this is the same project. So yeah, it's using that data there.
5 to 1 day. Okay. Yep. All right.
That's all you do there. And we'll
Okay.
have that in
That's
there.
easy. We can do that for sure.
Then you will need a control specifications file. And so you'll just create it. And that, all you need to do, put a start date in there. We usually say this probably was started. If you put it in the future, there'll be no mistaking that, oh, this isn't some storm that's already happened, but it doesn't really matter. We know what if you built the model, you know, and you're gonna just looking at it, you can figure out, and other things in the report will say, hey, this was built off Atlas 14 and stuff. But that's just, you have to give it a start time, and then you have to give it an end time. Usually give it 3 or 4 days, unless you have some super long time of concentration that's like 4 days long, then that should be plenty of time to let the hydrograph die off. And then you give it an end time. And then with that, once you've built those 3 components, you can create a run off of it.
Okay, so for the control specs, the time, you just want that to be greater than time and concentration. That's it.
Yes, the interval, for this, well, I usually make this about a couple days out to make sure we're running a 24-hour storm event. And then,
Okay.
whatever it doesn't take the program that long to run. So I just, the main thing is you should, if you go to, need to run one. If you go, and run it, and you looked at your graph, and if this, see, it keeps going till here, so I didn't need it to go that long, but it's better to just err on the side of too long. If it cut short like here, and you were trying to if you were trying to get the peak flow, I don't know if it would matter, but if you were trying to do a detention analysis and you cut it off while it was still going, then it wouldn't be good. So we just usually make it at least a few days long so it
Okay.
covers
Okay.
all that.
Alright.
What else? So once you get all of it, once you've built all that, the thing you'll have to do to get it to run is like there, I was able to just compute and pick one, but you have to create those and you just go like simulation. I say new, then you give it a name like 2-year or something, like 2-year. And then when you do that, you just create the basin model and the meteorological model and the control specifications, and then it's ready to select from it and run. So that's pretty easy. So that, and then you get your results off of there. You can go to,
You gotta go to each basin and select them.
yeah, you can go to your, um, you have a lot. You can go to these global summary tables, and sometimes it's probably going to be part of the process that I outline in here, but you may not. Like if we have a lot of these, then we'll copy this into a spreadsheet and let it do kind of the sorting for us.
Okay.
Because that has peak flow from each element in HEC-HMS. So that's that part. Okay, let me show you sort of.
And since we're doing this all on
areas.
HEC-HMS, we're gonna be getting tailwaters and stuff like that.
Well, not. What do you mean?
So you got headwater, tailwater for the culverts. You can use this same data to get that information. Or would you have to build a whole nother model?
Oh yeah, you will have to build. So this is just to calculate the flows that are going into your culvert. And then you would have to get the headwater and tailwater, you would need either a height model or a HEC-RAS model of your culvert itself. And then you would put the flows that you calculate using all this stuff into that.
I got HEC-HMS and HI-8 confused. Okay.
So this is just to generate some cues using the hydrograph method. So that would be, let's see. So the other big things, like we needed the area, which you have, and then you need your lag time here.
Yeah,
to be able
lag
to do it.
time.
That's based on the way we usually do that. So we've got this DC spreadsheet in the mix here, and that's based on this stuff, the NRCS method of calculating TC is in the TxDOT manual. So it's these equations for your sheet flow, shallow concentrated, and channel flow.
We're familiar with this stuff. Yeah.
Okay. So this, you need your longest flow path. You need, this first part can only be 100 feet.
Yeah.
And then we've set it up to default to at least 0.05%.
Okay.
If you've got these as exactly the same, otherwise whatever it calculates there.
Okay.
And I always tell people to like really look and try to get yourself the most sheet flow time as you can really justify, because it makes such a big difference. And if you find that your flows are like super high and unbelievable, you may have looked and picked a coefficient, and it may be reasonable, but you may just look and say, is there any way I could, that's a 338 contour, if I can just assume that it goes 336 and then at the last foot it jumps up to there, so I can flatten out this slope. Like it will dry, especially if you get to where your flows are like unbelievable, then mess with this and get your time of concentration to be longer. If your flows turn out perfectly reasonable, then you don't really need to do anything.
Okay.
But you just do all, so you got that 100 foot, and then you do the shallow concentrated, draw that in microstation, measure it, put the upstream elevation, downstream length, whether it's paved or unpaved, then it'll calculate that. This part, the channel flow, we've got it, this hydraulic radius here
Mhm.
is doing a lookup on this tab,
Mhm.
which is you need to pick a section for what your channel type is going to be, and then write the area over here, and then just kind of, so if I chose triangular, and I would write down what, so if I chose this section, I would come in here and write down 10, 1, 5, and then what the radius was. This is being calculated.
Yep.
And then this is just kind of storing that to use. So this you just type in, and then it's gonna look that up based on your area name and
Yeah.
put that hydraulic radius in, then it'll calculate your velocity based on that. And then it calculates your lag time down here, your TC, and then your lag time, which is just 0.6 times the TC. So this should be a pretty straightforward process. It takes
Yeah.
a little bit of time, but nothing. So, and then, okay, the other thing,
Okay. That ain't too bad. It's the same as rational method, same thing.
yeah. So the only other thing is the curve number, and so that is,
Yeah, that's where. we're
yeah.
kind of-
So let me show you the,
We haven't looked at the drainage manual once. We haven't had to look at
No.
the drainage manual at all.
try to get it. Okay,
All right, he's got a
so
workflow.
this, I'm
Go.
working on this.
Love this.
And so you do need to use this, and we'll walk through the spreadsheet, maybe because there's a way to do it without this, but if it depends on how big it is, but what you'll need is this ArcGIS Pro version 3.1.2 or later.
Is
And
that
then,
you don't get that, and you can just ask them to download it for you. You don't need it
Yeah.
from your machine.
you'll have to do a request for it.
Right. Easy. And there's a
And then-
login maybe.
Yes. There is, no, there's not. Once you get it, you should be good. And then the
Okay.
other thing you need to do is, do I have that? I think I should show that. Yeah. Okay, so you need to download this thing from, it's under Project Wise, under the reference material folder, and then WRE Tools, Innovation Committee, Esri add-in. There is a newer one, and so that probably works too. Or as long as you get version 1.5 or 1.05 or later, it should work. And then you need to close out GIS Pro while you're doing that. Export that locally, and then double click on it. Okay, and then when you see it, so this picks up, let me see if y'all would be able to follow from where this picks up. But because I started at point 2, and then I was gonna part 2 of this workflow, and then I was gonna go back and do part 1 later. But okay. Have either of y'all used GIS before?
Not really.
Not much. Okay.
No. Zero experience.
So what the workflow assumes is that you will have, so when we do our drainage areas, when we do any design, right, we usually work in surface coordinates instead of grid.
Yep.
And then everything GIS is in grid.
Okay.
And so what I recommend when you're doing a land use file, start that, give it your coordinate system, your state plane that you're in MicroStation. And this is in MicroStation right now. So give that the correct, or give that the coordinate system. And then when you pull in your drainage areas, apply the scale factor so that your file, when you're drawing in the land uses, you're in grid coordinates. Does that make sense?
Do that in the DGN.
Yeah, in the DGN. So you start a blank file and then you make sure coordinate system's assigned. And then you reference in your drainage area map, but you apply the scale factor to it.
Yep.
And then you draw your land uses. So your land uses, and then you should be able to, when you do that, you should be able to see the background map from Google.
I see what you're saying now. Okay.
And then you pull it in here and it's going to be in the right location. This tool.
We have a land use DGN. That's what we'll have.
Yeah. So this.
How do you know what? Are you gonna talk us through how to know what land use is which?
Yes.
Okay.
So we have what we've built the tool for. I picked several categories that I think will should compass most anything. So this is what the options will be. And then you have to, so in your DGN, you just want to name it something that makes sense to you. But when you do these GIS steps, you have to name and when you're getting the last step, especially, and putting it into a geodatabase that the tool is going to pull from, you have to name that feature class exactly like this.
Okay.
So you can pick from all these: woods poor, woods fair, pasture, meadow, quarter acre development, half acre development, acre development, industrial, commercial, paved, and it's going to use all these. And I haven't tested the rational part of it, but it should be using these rational coefficients, and it's going to use these curve numbers depending on what soil it's in.
Okay, so we just got to pick. We just make our areas and.
Yeah, and you don't have to go crazy. I mean, you can just have a few of them that you think cover enough of your project. Now, the one thing, and you don't have to cover everything, so it gives you the option of using this one, I think this pasture good or the brush good as a remainder land use. So whatever you don't choose gets assigned to the remainder, and it gives you the option. So whichever one you're going to do for that, you don't draw any shapes for that.
All right. So we'll draw shapes. Do they we draw shapes in the DGN per land use? Do we need to? How does it know?
So you draw the shapes,
how does it know
and then
which, and then whenever we import it, then we just assign the shapes after we import it. The land use. Okay.
Let me see if I can show you that part of the.
All right, so we'll draw shapes. There's a few ways to draw shapes.
Yes.
Is there a specific way of making a shape, or?
Don't do like a fancy type of shape. Like, I don't know, I would just do basic shapes and not like the groups or anything,
Yeah. So don't do graphic groups. We could just do smart lines and trace.
I would do full shapes though.
Okay, and then
Polygons.
connect the smart lines to make a shape.
Yes, like make sure they're like closed polygons.
Perfect. I gotcha. All right. And then you tell it a remainder. So you come in, make your polygons. But say,
Yeah.
for example, you don't.
Whatever you don't draw her in for it.
I'll show you. Let me show you that part. Or so you'll make your polygons. Let me see if I can get this. So, and then so you'll do that in your DGN. You need to assign the coordinate system to one of the state planes.
Yep.
And then you'll come in and create a new arc map, GIS Pro, and so then you can go to catalog. See if I can find where I put this stuff. Folders, computer, see. Where did I put it?
So whenever do you bring in your drainage area shapes as well?
You will export just the DGN. You don't need to, that doesn't need to be in grid coordinates or anything. It can be in the normal surface because the tool has a spot for entering the scale factor.
Okay.
So I think this will help, or actually I shouldn't have done it that way. It's gonna take forever. Okay, maybe that worked. So remove. Okay. I think I can remove that. So you brought it in. It may not know. Somehow it knew. It may not know where you. Let's see what its coordinate system is, but it. So you go to properties, display, source.
Okay.
So somehow it knew. I think when I first did this, it did not. And so if it doesn't know, you go to this define projection. So you would enter define projection and then let it know that it's in your state plane coordinate system. You could go browse here for it into projected state plane. Nat 83, 2000 US feet, and then find it here.
Okay.
But it seems to know that here, so this is what it'll get from the DGN, and then you have to do, like, I'm just gonna do a few for a sample. So this woods pour, you'll have to export each one to a feature class, or you'll just, this part I need to write down, but it's basically you can export it.
Did you already assign a shape woods pour? Or
So
are all
that's
these
what I named it in the DGN, and remember, in
Is
its
that a-
final form, it needs to be in called this. So woods pour would be this P wood.
are
So
those, is that a level? Is woods pour a level?
yeah, that's a level in the DGN. So you can name
Okay.
your levels accordingly.
Okay.
As always. But so since I'm eventually going to call it, I might just say, let me call it just woods pour again, because I know I'm not going to use this one quite yet.
Okay.
And then I think the other part would be to use the repair tool on each one. repair geometry. And I'm gonna do woods pour and just do run. And then it did it. Not 100% sure that's necessary, but it just, so there it is. There's only one. And then I would do, so the other thing you'll need, so where all of this stuff will be. So if you go to this part, insert, you want to make a, whoops, you're going to make some kind of a file geodatabase for all your land uses. And so you just save that somewhere.
And do you have like Windows? Do you have Windows like 30 or something? It looks different.
I don't know what's, some reason everything's like coming up really big today when I restart my computer. So
All
I
right. So
created
you
that
need to
into a
assign it.
database.
Is
The
it?
other thing you have to do one more thing here with your, before it's like completely ready, you do a
You following?
what's it called?
Well,
Oh, dissolve. It needs to be dissolved with the data management tools. And then you'll,
Dissolve.
yes. And then also, okay, I'm gonna keep it this, so this is not gonna be where I pull it from for the tool, because the geodatabase for the tool needs to be really clean. So I'll just keep it like that. It's, maybe that would have worked if I put it in there and named it the right thing, but when you dissolve it, it creates one feature. I think there only was one feature. It creates one feature of all the shapes and kind of dissolves them into one. And so then you're gonna go data, finally export features, and then you're gonna find the geodatabase that you actually want to reference for the tool. Which I called test run. And then you're gonna call it the actual name, which was PWOOD, right? Porwood.
And this is making it readable so it can.
Yes.
You know, you're translating. All right.
Yeah. And now, so you'll do that for all your land uses that you have, and it'll be in a geodatabase. So then you got this tool here. You go JMT water resources, SCS curve number. And then you'll put in the, so I'm gonna just go get your drainage area DGN that you downloaded. So dun, dun. Should be somewhere in here. Downloads everything if you got them all referenced.
Oh man.
Hopefully y'all won't do that, but it's that one. That's what I'm looking
The
for.
drainage
So,
area.
yeah. And then you give it, so because the drainage area map is in grid,
Okay.
I forgot what my scale factor is. I think it's I think I have it here somewhere. Yeah, that's what it's at. Okay, 1.00012. It says B dot, but that's just any scale factor. And then you're gonna navigate from here to your land use GDB. That's got everything in it. So that's this one's got that stuff in it. And then you're gonna select your remainder. So
Okay, so anything outside of the P wood and inside of the drainage area map.
so your remainder is either going to be, you want to select either the G brush or the G pasture, and then whichever one you do. So I did some G brush in there. Actually, is that right? Yeah, G brush or G pasture. I'm just gonna say, let's say G pasture for my remainder here. And then you run it. Oh, wait, no, you give it a output directory first. So I can. Two,
17.
say okay, and then you can run. It takes a little bit. Okay, and then with that, one thing you'll want to check. It's still running. Okay, so it is going to create a shapefile and a spreadsheet. I'll give that some time, but this one. So what it's going to create is, okay, the spreadsheet starting at this purple. So it creates a spreadsheet that's going to look a lot like this.
Okay.
So you have only a few areas, so it'll do one for each shape that you have in your file, but it doesn't really give it, there's no way of it like knowing what you actually named that shape. So that's, then it's going to give the total area, which I found a match with your shape. So it's, what I do is I take and in this part I've got written out in the workflow. So this is kind of where my workflow starts. The other stuff I have not written
This
out.
helps you
Like,
filter it out and stuff. Filter
yeah,
out with range area.
yeah, like creating that land use and creating the feature class. When I started this workflow, I did it because I knew I'd split it up. So it starts assuming that you have all that stuff and then you're doing it. So actually all the stuff I just showed you is in there except for the how you would create it with the dissolve and everything like that.
Okay.
So
We'll refer to
here,
the video.
yeah, from there, and I'll walk you through this part real quick. So that actually this is all part 2, and then part 3 would be this. So you're gonna, this is what it's gonna create, the shapefile. Then I say to navigate to that in GIS Pro, you'll add it in, and then you'll reformat the area to where you can actually see what's going on and just check that it did the translation correctly. Make sure that makes sense, and that you didn't put the inverse of the scale factor or something like that. And then this is the tool that it has. So then I have in the Texas Pelicans, go and copy and paste values to here, and you'll paste all that. And then I walk it through, but to give you like a really quick overview, you would copy all that in and then you would go through So it's got the total area column, so you can either, you'll go to this BD without inserting rows or anything. I tried to leave enough space to where if we ever have more, it's fine, but in BD, you will enter the names of your areas.
I got the pictures of everything.
That's fine.
Does that make sense? So you would look at like,
Yeah. You
you'd look at total.
The areas are what is the key. Yeah.
Yeah, yeah, so you just need to, this has the shapes and you can pull those in. Let me see. It's probably done. So if I go to GIS Pro land uses, this test. It's still running. It takes a few minutes. But when you add it back in, like you can select on them in GIS and see which ones they are, or you can say, you know, if you have 3 areas and you know which is which, you can just, okay, now manually input their names here.
Yeah,
And
that's
then-
probably what's gonna happen.
Yeah, and then the next tab is automatic, so it just takes your names that you have and then formats the rest. So you don't have to do anything on that tab. And this is all in the part 3 part. And then this part is automatic. I didn't have all the data for some of theirs, so that's why I have NAs on mine, but this just pulls in. This is just for a quick, if you want to check what the curve number is for the area. So that part's automatic. And then this part should work fine. This is only like, because this is so overwhelming, I don't think I'll ever submit this as part of my drainage report or anything. I think what I'll do, what I made this for was, it sums up the acreage of every soil type for each land use. So I might like include something like this in a drainage report saying, okay, this is the land uses we'd have for DA4 had 7 acres of poor woods poor, and then and I think it might be, it's actually in square feet. Because I have times 43,560, so this is square feet, but I need to fix all those, but yeah, that's only what this is for. And then I've tried to trying to make the rest to where it'll format what we actually put on sheets would be what, let's see, this tab would read the curve number from the other tabs that we just did, and it would calculate. Yeah, it's set up. It's just got some with incomplete data, and then I haven't done the coefficient, and it will make it. Now the other thing would be, it would assume that we would copy the HEC-HMS results for each run, and then it's gonna create this. This is pretty much automatic. It's going to create the summary that we would put on a sheet, something like this. So most of the stuff is fairly automatic. I need to clean it up a little bit, but it just requires you to copy your HEC-HMS. But as far as just getting a curve number, you just run that tool and it will, I mean, it's got it right there. I just am trying to go through more steps to get it to where we can just plop this onto sheets and stuff fairly quickly.
Trying to automate it a lot more
Yeah.
I totally understand that. But in the end, this is our curve number that we'll use.
Yes. Yeah.
And then
The
we'll put
only
that-
to that, yes, that would be a curve number, and then I need to do something. So remember how I said the land uses, that I usually do. So this pavement within right of way. So that's what the way I do it. I draw the pavement within the right of way on this layer and then I count it as if it's not paved. And then I need to measure that area as a percentage and enter that directly into HEC-HMS. If you wanted to just, you don't have to do that though. Like for what y'all are doing, you might just put it as this one paved. So if you do R paved, that's why that's there, so that I can, that's especially important if we're gonna like compare pre and post conditions.
Okay.
It might not be that critical for you guys, and you just use this one, which already has developed land use in there, the pavement, like 100% impervious.
Okay.
So,
I think we'll do that. Our pavement's not gonna change very much. We're gonna add maybe 10 feet of impervious,
okay,
maybe. That's rounding, that's being kind of generous. Maybe have 12 in some spots.
but yeah, that's
Okay, so we could just do paved and not worry about what would our percent impervious be whenever we input HEC-HMS.
so if you did that, if you use the paved one, then you don't even enter a percent impervious because you've accounted for it in the curve numbers you chose.
There'd be 0.
Be 0. Yeah, that's only for if you're not accounting for it in some of them and you're entering it as a percent impervious.
Okay, and this is, all right, so now we got through all the, from GIS, we put in that curve number into the drainage area in HMS. And
Yes.
then what more do we need to do in HMS, I guess?
That's it. Once you,
I mean, what
yeah,
value, I guess, why do we
run
care
it,
about HMS? Can you
'cause it's
remind me why we
gonna,
care about it?
it's gonna get your, when you're done putting that in there, then you can run it and get your flows for all the different events. So you'll have, so you would run it for each event and then copy the results. If you're using this stuff, that you would copy that into the HEC-HMS raw data. So
Okay.
peak discharge, and then
So the Excel doesn't do that for us. The
yeah,
HMS does the flow. Okay.
yeah, the HMS. The only I've just set this up to once I get it. Why is that not working? I need to fix it. Oh, it's still looking on another one. I need to. It's gonna read. What I want to do is make sure our areas are simple. So it's the areas and stuff. It's reporting based on the very first tab we have in this spreadsheet. This one here, where we're just entering our generic area information, like the measurement. And then this is going to be based on the tab with the tool. And then this is going to be based on a tab with the lag time, abstractions and equation. This will be based on the output from the tool, previous cover. And then this will be based on where you copy in the
Okay.
HMS output.
Okay.
Raw data here.
And you put the initial abstraction, that's a data point that you put in HMS, right?
Yes.
Okay.
Can be. It does. It's not gonna really do anything if you do or don't. So
Okay.
I haven't tested it in a while, but this is the equation for it, and that's what it uses as its default if you don't put anything in. So
All right.
wait, 6.4. Let's see. Yeah, so
Okay.
yeah.
So we have one, we got
This is what I'd recommend. So like this stuff, let me see. Only thing I haven't previous cover, so probably do. It's nothing.
Nine. Nine drainage areas.
Yeah, so. I guess my question about the land use is, are you just drawing in like what you're seeing, or are you, how are you going about getting that? Other than just-
So I have it open. Let's see.
We could show you ours. I don't know.
Yeah, so I'm
I don't know if
using,
that would help, actually.
you don't, you'll, to be able to use the tool, you need to use one of these ones we've got defined. But you can probably just, if you have used, there's tons of choices available. So if you've chosen something else, you could probably just recategorize it as that. Yeah, we can take a look. Oh, let me see. It popped up. Did it? It finished, I think. So if I go. Mm, did I forget? I don't know if it worked. Hold on. Oh, there it is. Okay, so if I add that to the map, once you get it, you go to Art Catalog here, catalog, go to the output directory.
Okay.
You add the shape to the map, and you can see it.
You
And then you can make sure I usually click on it and then make it just an outline. Then you can check that it translated correctly, which it did. Looks like. So yeah, see if I add a new map. So I just try to hit everything, and I do this in DGN with the aerial, but if I see, let's see, what's that, woods fair, woods good. Turn on off. So this, all these woods I put as woods good. We did a couple iterations. I think our flows were coming out too high and it was causing flooding, which had never been recorded. So we kind of went and justified as low a curve number as we could by giving them like the best of the land uses that we could pick for that category. So if it was like woods poor, we went and changed it to woods good or something like that. But like we taken areas like that and just kind of generalize it like, oh, that's a meadow or something, you know. It's just trying to classify everything. But this is like the right of way pavement I was talking about. I only count what it did there. So
your drainage areas are including in the right of way. Is that right?
yes.
And your ditches are gonna are gonna be big enough for to fill for all these externals, right? You're gonna
Right.
use, they should be big enough to meet the capacity of all the water going into it. All right. And then,
For like a,
okay.
for like a river or something, a drainage, an actual ditch or something, do you have to classify that differently? Like, say you have a pretty big or pretty long river or whatever we call it.
Like in here we have, I just put what it, like, this is all a floodplain. So I just, at least on this one, there might be other, I think from that list, I just put it based on, you know, if it's woods or brush or pasture. So not really anything to differentiate whether it is a river or not. So I would just, it would be pretty hard, at least this stream, to make out where exactly it is. It's kind of in the middle of the woods. So I just put it as including it in that. I guess if it was wide enough, maybe you could include it as something else, but it would get, you wouldn't want to do, it would almost be like, it becomes, there is a stream. So if this were like from here to here, like the Mississippi River or something, then maybe I would count that as almost gravel or something really high because there's no infiltration. It's going straight in. But other than that, not really. If
Okay.
I understood your question correctly, at least.
I guess I'm just making sure that when you're talking about your drainage area, you kind of have, say it's a river, right? I mean, I guess you're including that in your classification of your land use, although that's part of your catchment of your watershed.
Yeah. Usually if it's like compared to the whole size of the area, and then like the creek itself would be like really small. So, I mean, even though it's a pretty significant creek, so I didn't
Oh,
worry about differentiating it.
okay.
All right, so we gotta differentiate. How do we, are there descriptions for each of these woods fair, poor, brush, like? Yeah,
Yeah.
I guess it's all in the manual.
Yes.
All right,
Yeah.
or do you have it labeled somewhere?
Yeah. I'll send you this.
Yeah, and
It is in the manual. What it is it's about the ground cover. Do I have it in here?
Yeah, it's percentage.
Oh, grass
There you go.
cover.
All right, cool. And we're not distinguishing between A, B, C, or D at all.
You're not. No, the tool. So the only thing you have to worry about, you can check your, you have Google Earth, I guess. You have the tool to look at if you're between counties in your drainage area, then I mentioned somewhere in there. So it's pulling the soil data and it's going to pick one. So you'll have to go into the, if you run into that, you'll probably want to get with me, or probably actually I would probably pull into Bean, because I think what we have to do is if you do fall into in between two counties, which is unlikely, then you have to like take the soil data from one, add it to the other, and then merge it together, and then do that for both of them, and then drop that into their county so that it includes both counties, and then that way it'll work no matter what. So if you have this, do you have this? I just found this recently. This generate Texas layers. from TxDOT, and then you can tell what
Wow.
county you're in. I'll send that to you. It's a tool, a KMZ tool, and it
It shows the county lines.
Yes.
That was it.
It's the county lines. So if you
Oh,
are,
that's beautiful. And the districts, check that out. All right.
yeah, if your drainage area goes between two counties, then we have to combine the soil data that's on ProjectWise that the tool is using.
Yeah, I don't think we have that issue. Thank goodness. One less thing I gotta worry about, right?
Yeah. That all makes
Hydrant thing,
sense.
it's no joke. A lot of steps to the
Yeah.
GIS that we need to get down. I think we'll be watching the video over and over again for the GIS stuff, a picture.
Do we have a copy of those workflows or is it we send them?
Yeah, I think he'll send them. You'll send us all the workflows and Excels and all that.
Yes, I'll send you that
Um,
the other day. Almost done with cleaning up the spreadsheet and all.
okay.
The only thing I haven't tested, and you did the rational method, so there's also a rational one that I think it's the runoff coefficient based on using, so we're just trying to
It does it based off land use. Okay.
yeah, we're just trying to make this thing like do everything, but so it's gonna base it off each land use has those, and then it's I haven't tested that yet, but
So I think I saw you
Here.
searching in your local for land use, like database.
yes.
Is that something that we need, or will the GIS download that to our local for us?
So you'll bring this DGN in, and then when you're cleaning up each individual to put them in the thing, then when you'll do the repair tool, and then you'll export it, do the repair, and then dissolve it, and then you'll import it into the geodatabase that you're going to use for your calculations. And so you'll make a new one
Okay.
using
Make
this
sure.
right here.
Yeah.
Ology
Okay.
database.
And then
You'll save that somewhere local, and then that's what you will use for like this one. See, it's got all the different, and all these are dissolved into one shape, and then they've been repaired and they're ready to be put in the tool.
okay. Okay, so these are ones that you've already made. This is an existing project that you've got the meadow and the industrial you've used this for, or is this the database? The GDB is the
Yes.
database that houses.
Yeah, this is all the ones I made for this project.
All right. So you bring in your shapes, and then export, dissolve, repair, and then send it to your local for a GDB to your local, and then
Yes.
it's going to assign. You do that, you assign it by hand. I feel like you've already explained all this, but I'm having a hard time remembering. I feel like
Oh, that's okay.
I feel like you've already explained it.
So
but
that part,
we've learned so much. But I think I'll refer to the video.
let's see,
If
part
you have any questions.
Yeah, the video for making the land use, because I haven't written that up yet. And then once you have it, using the tool, all that stuff is in
Okay.
here. As well as the land use categories you can use. That should be in here. So yeah, probably the hardest part is the part that I don't have written out and that we.
Yeah.
So,
We'll save it. We'll do it. We'll get it later.
and then but the spreadsheet, yeah,
It's
all
funny.
that stuff about where to put it once you've run it, that's in part 3. So it'll come out, and then you're gonna take spreadsheet, copy it into this tab, and then going from there, it should all be easy to follow.
Okay. I feel pretty good.
Yeah. Just don't
I-
insert rows because I had to do, or don't, for the ones, a lot of them, they're like, or a few of them I've said, like, don't insert rows or columns because I had to. This, in order for me to combine them back, which I don't know that you even need, but I'll probably want that at some point.
Okay.
I had to get it to add up every one that it's getting from all the different soil types. So I had to make like a weird equation. So
All right. I got you. And there's a note in there that says don't touch it.
yes.
Yeah, I have a little after, but you have a bunch of, a bunch of cells. All laughing.
Yeah. Yeah, I think this is good. We have something to work off of, and then if we're missing a step, it's easy to ask a question because
Yes.
I'm on this step, but I can't get to the next step. So please
Yeah.
help with this step. So that it's nice to have a work through or a walk through workflow so we can ask questions based off the walk what work